Hey guys, welcome back to Car Academy. In this video, we are going to look into interview question contains duplicate. It's a famous interview question. The question is, we are given an integer array nums and we'll have to return true if any value appears at least twice in the array and return false if every element is distinct. Okay, so we'll first take a look at this example. So this example has four numbers in this array. So you have these four numbers 1, 2, 3, and 1. So in this case, the number is 1 is actually present twice, which means that we'll have to return true in this case, in this example. Whereas the other numbers are just present once, but that doesn't matter. As long as there is one number that contains duplicate or at least present twice, we'll have to return true. Let's take a look at this example. So this example, we have again four numbers 1, 2, 3, 4. Each number is present only once, so in this case we'll have to return false. So that's the problem description. Now we'll implement this problem in two different techniques. First one, let's implement this in a brute force technique. So in brute force technique, what we'll be doing is we'll take an element in the array starting from the first number and we compare that with each and every element in the array. So if this element is present, then we return true. If this is not present, then we go and take the next element in the array and compare that with the subsequent elements. If it is found, we return true, otherwise false. If it's present, we return true. If not, we go and take the next element and then start comparing. The process goes on till we go to the last element. So that's the brute force technique. Now let's go and implement that. So in the brute force technique, this is the problem, contains duplicate. So in case of brute force, what we are doing is we'll be doing this with a nested for loop. The outer for loop, we parse each and every element, and in the inner for loop, we will have to take the element next to the element that's sitting next to the element that's the outer loop is pointing towards. So at any point of time, what happens is, I'll explain the process here. So the process is like, in the outer loop, this is the outer loop. The outer loop is responsible for taking an element from the array, and the inner loop, this is the inner loop. So inner loop, this is the one which we are comparing each element with the element taken by the outer loop or pointed by the outer loop variable. Okay, so that's what we are going to do now. Okay, so here is the logic. If nums of I is equal to nums of j, what that means is the element pointed by the outer loop, if this is equal to the element pointed by the inner loop, then we return true. So that's the only condition that we will have to do. So if none of the element is matching, that means we come out of the loop, both inner and outer, and in this case we return false. So now let's go and run this code to make sure that there is no compilation error. Okay, so it says it's accepted. So what that means is the solution has been accepted. So let me explain this problem again, this implementation again. So you have an outer loop. In each iteration, we'll be taking an element from the array, and that element will be compared with each and every other element starting from the next element pointed by the outer loop variable. So why don't we start from the beginning? Because we have done this process from 0, So if I is equal to, let's say, 2, we don't have to do that for j is equal to 1 and j equal to 0, because that has been done already by the outer loop. So when I equal 0 and j is equal to 2, it is same as I equal to 2 and j is equal to 0. So we don't have to repeat that process. So the time complexity for this particular implementation is, since there are two for loops, so you have n elements in the array, and we are doing this using two for loops, which means that the time complexity is O of n square, and the space complexity is O of 1, because we don't actually save any element. Okay, so this has been accepted. Now let's go and see how we can implement this in an optimized fashion. Okay, so let's see what's the technique that we'll be using to implement this with the optimized method. So now we are going to do this in an optimized method. So now in the brute force we use nested for loops, right? And it has this O of n squared. In the optimized, if we can get that with O of n or anything less than O of n squared, that will be considered optimal. So here the problem is that we just need to find the duplicates, right? So let's take this case 1, 2, 3, and 1. So what we just need to know if this element has already been parsed or something like that, right? So the good data structure for this particular use case is the hash set. So in C++, hash set is implemented with std unordered set. So what this means is you have something like a hash set here, and initially it contains empty. When we take this element, let's say when we take this array, when we take the first element 1, we check if this element is present in the hash set. This is the hash set. This is implemented with binary trees, and it's so fast. Okay, the hash set is not implemented with the binary trees, but we have certain algorithms to get that in O of 1 time frame. Okay, so the first element 1 is checked if this element is present in the hash set. It's not present, so what we'll have to do is we'll have to put that element in the hash set. Now let's take this number 2. We check if number 2 is present in the hash set. If it's present, we return true. This is not there, so we will be putting that number in the hash set. Then we'll go and take the number 3. We check if it's present in the hash set. If not present, we add it to the hash set. Now let's come to this number 1. We check if this number is present in hash set. Yes, it's present, and in this case we return true. Okay, so it's as simple as that. Okay, now let's go and implement this in C++. Let's erase this. What we will need is a hash set. Okay, so we'll be parsing from the starting element till the last element in the array. So we check if hash set dot count is the same function that's also available in hash set, like the hash maps. So you check if this number is present. If it is present, it returns a non-zero value. So in this case we return true. If it's not found, what we will be doing is we will be putting that number into the hash set, so which is hash set dot insert nums of I. That's all. If none of this is found, we finally return false. Now let's check if this code is compiled properly and all test cases are working. Yes, this has been accepted. Now let's go and submit this. So it's saying, yeah, it's accepted. 71 milliseconds beats 46.89% of the code. So yeah, that's all. So we implemented this problem in both the brute force and also in the optimized method. If you know any other better technique to implement this, comment that under the video. If you have any questions, ask it in the channel. I'll try to respond in the timely fashion. Yeah, if you like this video, share it with your friends, subscribe to the channel, like this video. Until I record the next video, I'm signing off. Thank you guys.